In this video lecture, we shall see the basics of MOSFET, and we shall also discuss what is an nMOS transistor. See, MOS, it stands for metal, oxide and semiconductor. So basically we have three layers, okay, which are manufactured using a series of chemical process. Okay, that's why we call it as a sandwich-like structure. So you have a metal layer, which is a conducting, you have an oxide layer, then you have a semiconductor layer. Okay. Now, in MOSFET, the operation is controlled by the electric fields. Okay, if you remember the BJTs, the operation was controlled by the biasing currents. That's why we call BJT as a current control device. Okay, whereas in MOSFETs, it is because of the electric fields. Okay, which we shall see later. That's why MOSFET is called as a voltage control device. Okay, that's why this is what the field effect word reflects, that the operation is because of the electric fields. Coming to the three layers of the MOSFET, you have the gate, which is a conducting layer. Okay, and earlier this gate was built by using the metal. Okay, later uh, it was done by using the polysilicon. Then we have the other layer, which is the insulating layer, which we call it as the silicon dioxide. Then you have the substrate, or we call it as the body or bulk. So in CMOS, there are two types of transistor. One is N-type and the other is the P-type. Let us see the N-type. So in N-type of transistor, you have a P-type bulk, okay, which is moderately doped. Okay, you can call this as body, substrate, fine, or like we have given many names here, or silicon wafer, or even you can call this as bulk. Okay, normally it is referred as body. Okay, so this is the first layer, that is the semiconductor layer. Okay, then in this P substrate we are diffusing two N plus impurities. So this plus sign indicates that it is heavily doped. Okay, so this forms your semiconductor structure, and remember, this is only a two-dimensional view. Okay, you can refer any textbook for a three-dimensional view. Okay, now on this you have a insulating layer, which is the silicon dioxide. On this you have a polysilicon, okay, which forms the gate terminal. Okay, so these two N plus impurities form the source and the drain terminal. So that's why we can call MOSFET as a three-terminal device, which has got gate, source and drain. Sometimes this body is also referred as the fourth terminal. Okay, now let us see how the conduction takes place, or how a channel is established between drain and source. Okay, as you have already seen, the conduction is only by the electric fields, that is by the application of the voltages. Okay, that we shall discuss later. Okay, fine. Now, in order to understand the establishment of the current and the controlling between the drain and source, basically there are two modes. One is the nMOS enhancement type, and the other is the nMOS depletion type. Okay, now this is the structure, two-dimensional structure of a nMOS enhancement type, which is in detail. Okay, and this is the nomenclature you have to follow while drawing. Okay, so if you are not drawing, then you indicate by arrow mark that this is P type, this is N type, and this is polysilicon, and this is silicon dioxide. So you have to mention it if you are not following this nomenclature. Okay, now we have already seen this is the P type. We have diffused two N types. So whenever you join P and N type, we have a depletion layer. That is what it is shown here. Then you have a silicon dioxide layer. Upon that you have a polysilicon, and how are the connections taken out? By depositing a metal layer. You can see on this N plus type, you have a metal layer. From that the connection has been taken out, and it is the source. Similarly here, metal layer has been deposited and a connection has been taken. This is the drain layer. Similarly, a metal layer upon this polysilicon, which is the conducting layer, it forms the gate layer. Okay, so in this we will only understand what is a enhancement type transistor and what is a depletion type transistor. We will not go in detail how the channel is established, but we will only mention the condition based on which the conduction happens. Okay, so that part will come later. Okay, now initially there is no channel being established. That's why the enhancement of type of transistor, it is normally called as off. It is normally in off condition. Okay, that is when you have not applied any voltage to this gate. Okay, so when gate voltage is equal to 0, that is for nMOS type, no channel is being established between the drain and source. Now, what is the condition for establishment of channel? You apply a gate voltage, okay, a positive gate voltage, such that that gate voltage should be greater than the threshold voltage. Okay, now as of now you need not worry what is threshold voltage and all. So when this gate voltage it is greater than the threshold voltage, then a channel is formed between the source and drain. Okay, so that is why the word enhancement type, it itself tells that there was no channel earlier. So enhancement means that you are enhancing the channel now, okay, by applying the gate voltage. So an nMOS enhancement mode is one which is normally off, and when you apply a gate voltage of greater than the threshold voltage, a channel is being established. Now coming to the nMOS depletion mode, this is normally on. Okay, all other things remain same. How is it normally on? It is normally on because we are introducing impurities between the source and drain to form a channel. Okay, which we call it as, use the word called implanting. We are implanting, that's what has been said here. See here, in case of depletion mode, a channel is established under the condition VGS is equal to 0. You have not applied any voltage here. So VG is still 0 by implanting suitable impurities. Okay, so you are implanting suitable impurities between the source and drain. So the channel is already present even though gate voltage is equal to 0. That's why it is called as normally on. Now how can you break this channel, or how can you remove this channel? You can remove this channel by applying a negative gate voltage. That's why the word called depletion. Okay, so when you start applying the negative voltage, the channel starts getting depleting. Okay, and there will be a point when there will be a point when there will be no channel between the source and the drain. Okay, so to summarize, in enhancement type of transistor, okay, so no channel will be present, and upon applying a voltage, so in case of nMOS, a positive voltage, channel is established. In case of depletion, a channel is already there by implanting impurities. Okay, and upon applying a negative voltage, that is in case of nMOS, we can remove that channel. Okay, so you can go through the notes. Okay, in the next lecture we shall see a PMOS device.